All right, for today's lesson 5.4, sum and difference identities, one of the things that you will want to have handy is your identity sheet. We started filling this out with our identities, and we have not revisited. And now we, over the next 2 lessons, are going to fill in the rest of that sheet with the rest of our formulas. On each of the pages that I show formulas, you're going to want to pause and fill those in. Be very careful that you fill them in accurately. Let's go ahead and get started. Our first page is the cosine of a sum. What does that mean? It means we're taking the cosine, and inside of that is something being added. That's the word sum, being added together. And what we can do is we can rewrite that as the cosine of the first thing times the cosine of the second thing minus, notice opposite sign here, sine of the first thing, sine of the second thing. Go ahead and add this to your identity sheet. And like I said, we're going to fill in all of these in this section. So pause on any screen that you need more time on. Cosine, if instead it is a subtraction, that's where we pick this formula that says difference. Same setup, the only change is it should be an addition between the terms. So cosine of the first, cosine of the second, plus sine of the first, sine of the second. So we're going to go into when would we do this? Why do we use these formulas? And we're going to use these formulas when we are handed a question, something like this. Says use a sum or difference property to find the exact, and notice exact. This is all non-calculator work. And they're asking us to find the cosine of 15. Well, guys, if we think about the angles that we know, go to your hand trick, go to memorizing quadrant 1, whatever your method is, your special right triangles, we know things like pi over, degrees. We know things like 30 degrees, 45 degrees, 60 degrees, anything that falls on an axis, 0, 90, 180. And so what our job is, and so here's all of our options. If you notice, all the degrees are in the inside. So we're talking degrees on this particular problem. So let's look in here. We've got 0, 30, 45, 60. Notice none of these, the problem we were doing was the cosine of 15. None of these say 15. And so what we're going to do is we're going to go through, and here's the challenge, but also the nice part about this section is we are now going to take 2 angles we know. So some angle I know here, I'm going to add or subtract a second angle I know, and the result should be 15. And so we're looking for 2 angles that I can either add together to give me 15, or if I were to subtract them, they have a difference of 15. And we're going to rewrite that cosine of 15 as those 2 angles. So, oops, go back the other way here. For example, a very basic one right here would be here, 45 and 30. If I did 45, if we subtract 30, 45 minus 30 is 15. So if we come back here, I can break that 15 into 45 minus 30. We're breaking it into 2 numbers that we would see on the unit circle. And then we apply that formula that we just wrote down. And we'll pick the formula that matches whatever symbol we picked in here. So we picked the subtraction. That would be this one right here, cosine of a difference. We subtracted 45 minus 30. So we will break this into, here's my alpha, here's my beta from that formula right there. So it'll be the cosine of the first times the cosine of the second. Our formula, I'm just filling in from the formula on the last page, plus sine of the first times sine of the second. And then we just go through, and it's basically like giving me 4 questions from a gateway. So cosine of 45 degrees is pi square root of 2 over 2. Cosine of 30 degrees is the square root of 3 over 2. Sine of 45 degrees is the square root of 2 over 2. And sine of 30 degrees is 1/2. So then we're going to multiply, combine those terms there. It's just multiplying straight across the top, straight across the bottom. A little reminder on how do we multiply radicals. Well, those are both inside, so I can multiply the numbers inside together. Square root of 2 times square root of 3 is square root of 6. In the bottom, 2 times 2 is 4. Square root of 2 times 1 is square root of 2. 2 times 2 in the bottom is 4. We have fractions, and so we need a common denominator. We have a common denominator, so I can add those two together, keeping the common denominator. When I add, so now we're looking at the numerator part of this, when I add radicals, remember that they have to be exactly the same, or I cannot combine them. And so this would stay square root of 6 plus the square root of 2 separate. Now here's the deal. Almost all our unit circle values are going to look like the ones you see in this row. And so all of our answers are going to very similarly resemble this one. Different positives and negatives, but we're going to see the same answer showing up over and over and over, or the same format of answer showing up over and over and over because of the values we're working with. And again, that's our unit circle values. At this point, you need to know your unit circle really well. If that is, you need to go get a unit circle to reference, whatever it is. But we are going to be considering these values, and we can flip back to this page on each of these. Okay, so that's what it looks like if we're talking degrees. But what does it look like if we now start using the radians part of it? Well, here's the challenge on the radians part of it. So let's look at a problem in radians. Still dealing with those two different cosine properties, cosine of a sum, cosine of a difference. So what you're going to do in radians, what you're going to notice is it looks very different because we're looking at a pi over 12. And what I'm going to do is I'm going to break it into 2 fractions over 12. Okay, so we can go ahead and jump to something pi over 12 and something pi over 12. But the difference is, on this one, what I want to do is find 2 numbers that add or subtract to give me 5. Great. But here's the key on this, is that you need to pick them strategically. So things like 1 plus 4 gives me 5. Now, this is a bad decision or a bad choice because here's how I said I want to pick them strategically. You need to pick numbers so that the resulting fraction, like 4 over 12, will simplify. Now, 4 over 12 does simplify, but we need both fractions to simplify. 1 over 12 does not. So the decision of 1 plus 4 to give me 5 is not a good choice because that second fraction does not simplify. Why do I care that it simplifies? If we go back to our unit circle here, you'll notice that our options are over 6, over 4, over 3, over 2. Nothing is over 12, and so we need that fraction to simplify so we don't see a 12 anymore. So let me erase here. Okay, so again, we're going to create 2 fractions that have the denominator that we start with, something pi over 12, something pi over 12. So let's pick different options. Think about options of things that we can add together to give us 5. We tried 1 plus 4. You have other options which would be like 2 plus 3. You do have options that we can subtract. We can go 6 minus 1, 7 minus 2, 8 minus 3. Gives us a lot of options here, but again, we have to strategically pick so that the 2 numbers, when I put them in the fraction, will simplify with the denominator. So again, something like 1 plus 4 didn't work. Well, 6 minus 1 wouldn't work because 1 does not simplify with 12. Let's stick with a basic one here, 2 plus 3. 2 plus 3 works because 2 over 12 simplifies, 3 over 12 simplifies, and so what we get from doing that is a sum. 2 over 12 will simplify. The 2 and the 12, both divisible by 2, would become a pi over 6. The 3 over 12, both divisible by 3, divide by 3, divide by 3, we get pi over 4. And so this would break down into cosine of pi over 6 plus pi over 4. And then we look at the symbol between. It is a positive or a plus, so we would do our cosine of a sum formula, cosine of the first, cosine of the second, minus sine of the first, sine of the second. And again, that's not something I have to have memorized. We just get that from our sheet. And so we just follow that pattern. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. And then we now go to our unit circle and we find the value for each of those. Cosine of pi over 6 would be square root of 3 over 2. Cosine of pi over 4 would be square root of 2 over 2. Sine of pi over 6 would be 1/2. Sine of pi over 4 would be square root of 2 over 2. And like I said, at this point, they're all going to look very, very similar. We have to be careful with our signs here. Square root of 3 times square root of 2 is square root of 6. 2 times 2 in the denominator gives me a 4. Minus, and then a straight across the top again, square root of 2 over 4, which, as I put those together over the common denominator of 4, gives me a square root of 6 minus square root of 2. That would be my exact value. Okay, so let's see if I can answer a couple questions before we move on to some other examples here. First of all, does the order that I put these numbers, 2 and 3, or the numbers inside of here, impact my answer? No, it might look slightly different here, like these terms might be flipped, but no, it will not change our answer overall. Remember that equivalent forms are okay, so if I had a negative square root of 2 plus square root of 6 over 4, these are the same answer because the negative is still in front of the square root of 2, the positive is still in front of the square root of 6, so we would still be okay at that point. If you have a negative, make sure that that negative is on the 2 and that we don't slide it in front of the fraction. This would actually be an incorrect answer because that negative would actually get distributed to both parties and we don't want it distributed to that second term. So make sure you just keep the signs. Don't ever put that sign sitting in front of the fraction unless you intend for it to be for both terms in the numerator. All right, so very similarly, we have then formulas for sine of a sum, difference of a sum, sine of a difference, and same thing for tangent. And the process in the beginning, breaking apart the number, is the same. You just have to apply a different formula once you have figured out what two numbers you want to add or subtract to match the number that they give us originally in the problem. So go ahead and go back to your identity sheet. Let's go ahead and copy the sine of a sum formula in there. So if we have two numbers being added together inside of a sine function, it would be the sine of the first cosine of the second plus cosine of the first sine of the second. So very similar looking formulas here, but slightly different. Sine of a difference, same formatting, but different sign in the middle. So sine of the first cosine of the second minus cosine of the first sine of the second. So putting that into play here, we'll start with one that's in radians. So again, in radians, we will always just immediately start with two fractions over the denominator they give us. I'm going to pick two numbers that will add or subtract to give me 23. So again, remember, a bad choice would be something like 22 plus 1. Yes, that equals 23, but 1 over 12 does not simplify. So go through, pick a combination of two numbers that would equal 23. There is not one right or wrong answer. In fact, I'm going to do two different ones on this one to just show you that we could pick different options. I could pick an option like, let's see, 21 plus 2. Actually, let's pick something even more extreme here. How about two numbers that give me 23? How about 15 plus 8? All of those would be good answers here. 15 over 12 simplifies. 8 over 12 simplifies. Adding those two numbers together would give me 23. So I would end up with sine of 15 and 12 are both divisible by 3. 8 and 12 are both divisible by 4. And now I apply my sine of a sum formula. And sine of a sum formula says the sine of the first cosine of the second plus cosine of the first sine of the second. And again, at this point, if I flip those two numbers, it will all work out in the end. So please do not stress over the order of anything. But what you do need to be very cautious of as we start getting into these more complex ones is keeping my mind on all students take calc. This is now going to have a major impact, especially as we start getting into these bigger angles. For example, this very first problem, sine of 5 pi over 4. 5 pi over 4 puts us into quadrant 3. Well, sine is negative in quadrant 3, so my answer should be negative for 5 pi over 4. Reference angle being pi over 4, sine of pi over 4 is square root of 2 over 2, negative because it's in quadrant 3. Cosine of 2 pi over 3. 2 pi over 3 puts us into quadrant 2. Cosine is negative in quadrant 2. Pi over 3 for a reference angle would give us a cosine value of 1/2. Negative because we are in quadrant 2 for cosine. Next one, cosine of 5 pi over 4. Again, puts us back into quadrant 3 for that 5 pi over 4. Cosine is negative in quadrant 3. And pi over 4 is my reference angle. Cosine of pi over 4 is square root of 2 over 2. And sine of 2 pi over 3, 2 pi over 3 puts us into quadrant 2. Well, sine is actually positive in quadrant 2. Pi over 3 is our reference angle. It gives me a square root of 3 over 2 angle. And then we go clean this up. And again, we're going to be looking very similarly. The very first one, negative times a negative is a positive, square root of 2 over 4. In the next one, we should have a minus. Again, multiplying straight across the top, straight across bottom gives me a square root of 6 over 4. And combining those, we get square root of 2 minus square root of 6 over 4. As long as you have those two terms, either order is fine. And I told you I was going to do this one two different ways because we could add angles together, but it is actually okay to also subtract angles. So instead of maybe 15 plus 8, what if I subtracted two angles to give me 23 over 12? Two angles that would simplify with 12. So again, we'll make two fractions here, 2 pi over 12 angles. I'm going to subtract this time to get to 23. Let's see, what would subtract to give me 23? That would simplify with the 12. How about a 26 minus 3? Both of those should simplify with the 12, so we'd be looking at sine of 26 and 12, both divisible by 2. 26 divided by 2 is, let's see, 13 pi over 6. And our second one here, both divisible by 3, pi over 4. So this time it changes to a subtraction instead of an addition. We had an addition over here. This time we have a subtraction. So applying this time the sign of a difference formula. And that is sine of 13 pi over 6 cosine of pi over 4 minus cosine of the first, 13 pi over 6 sine of the second. And we got to talk about that 13 pi over 6 angle real quick. A 13 pi over 6 angle, well, 12 pi over 6 would be a full circle, so 13 pi over 6 is going to go one more and put us into quadrant 1 with a reference angle of pi over 6. So everything's positive in quadrant 1. Sine of pi over 6 reference angle would be 1/2. Cosine of pi over 4 is in quadrant 1, so positive. Cosine of pi over 4 is square root of 2 over 2. Cosine of 13 pi over 6, again, we already talked about 13 pi over 6 is going to put us into quadrant 1, so that's positive. And cosine of pi over 6 would be square root of 3 over 2. And sine of pi over 4, again, quadrant 1, so positive, square root of 2 over 2. Cleaning this up, we'd have square root of 2 over 4 minus square root of 6 over 4, or square root of 2 minus square root of 6 over 4, and you can see that we match the same answer. And again, if I were to switch these two angles the way I have them written in here, all that would do is switch my numbers at the bottom, but it would still be a negative square root of 6 and a positive square root of 2. All right, the last one is our tangent formulas, and they are a little bit more complex. And so what we have is if we do a sum with tangent, that you get a fraction, tangent of the first plus tangent of the second, over 1 minus tangent of the first, tangent of the second. So let's go back to our identity sheet, fill that formula in. And our second one, tangent of a difference. So again, we change now to a subtraction. Looks very similarly, but in the numerator, tangent of the first minus tangent of the second, over the denominator 1 plus tangent of the first, tangent of the second. Not formulas that we'll ever have to memorize, just know how to apply them. Okay, there is one note, and this is purely to try to help you to make things easier, and that is because of what we get when we do tangent of 30 degrees. So note, when dealing with tangent, you're going to try to avoid 30 degrees, and 30 degrees is also pi over 6. You're going to try to avoid that when possible. So if you could pick a different set of angles that would add together that does not include a 30 degrees, then I would pick that. How do you do that? Well, for example, if I was at the beginning trying to find two angles that added or subtracted to get 15, I went with the first pair, 45 minus 30. Well, if I'm doing a tangent problem, I really don't want to use 30. And so if we go back to our unit circle, there are lots of options that do not include 30. Or any reference angle of 30 for that. So we could have instead of gone with 60 minus 45, neither of which have a 30-degree reference angle. So let's talk about what angles we want to avoid with our tangent problems here. So in tangent, here are the ones that you want to avoid. We don't want to use 30 degrees, which is pi over 6. And what is that in each of our different quadrants? So again, just to try to avoid those. 150, or 5 pi over 6. In quadrant 3, it would be 210, or 7 pi over 6. And in quadrant 4, the one that has a 30-degree reference angle would be 330, or 11 pi over 6. If you can pick a different set of angles to help you with this, I would do so. And as you're looking at this, again, I would probably, let me get out of this, go back to just looking at your unit circle, and maybe printing this out for yourself can be useful here. As I look at this, so again, let me erase what I've got on here. And this is what I'm about to mark on here is specific to tangent, but having a unit circle might be useful to look at. Oops, I forgot to grab my pen. But we don't want to use the 30 degrees or pi over 6, the 5 pi over 6 and 150, 210 or 7 pi over 6, 330 or 11 pi over 6. So think through other options as we look at this. So the problem we were just about to do is the number 255. So if I look at finding, let me see if I can pull this down here. Two numbers that will add together to give me 255. Now, things again that we want to avoid. Something like 225, we're looking for the number 255. Well, 225 plus 30 would give me 255, but I don't want to use 30 degrees. And so if we are able to find another option, that would be ideal. So continuing to just scan through to see what we could do. So maybe we go the other direction. What if we were to subtract? What if I started at 300 and went down to 255? So 300 minus 45 would get me 255. There is a good option where neither of those is a 30-degree reference angle. So just kind of working through some options of angles around there that could get me to 255. So I think I'm going to use this 300 minus 45 again to avoid that 30-degree reference angle. So we'll break this into tangent of 300 minus 45 degrees. Still says tangent of 225, but now I can apply my formula. And our formula for tangent says tangent of the first minus tangent of the second over 1 plus tangent of the first tangent of the second. Now I know this seems like a lot, however there's duplicates. So once I find that first number for tangent of 300, that's actually going to go right here as well. So let's think about what tangent of 300 is. 300 puts me into quadrant 4 with a 60-degree reference angle. Well, tangent is negative in quadrant 4 with a 60-degree reference angle would be a square root of 3 angle. So I fill that in for both places that have tangent of 300. Now let's look at tangent of 45 degrees. Tangent of 45 degrees puts me into quadrant 1, so it would be a positive angle. And tangent of 45 degrees is 1. So I fill that in, and then we just do a little bit of cleanup here. Okay, now I'm going to tell you right now, if you can get to this answer, you are doing wonderfully. You would never see that answer in a book, and the reason is because of the radical in the bottom. So if you get to this point, you're doing great. However, let's look at how we would clean that up. Remember that if we are going to clean this up, we would use the conjugate of our denominator to get rid of that radical. So I would multiply top and bottom by 1 plus the square root of 3. And we'd have to FOIL in the top. So foiling in the top would give me, let's see, negative square root of 3, negative, that was here. Negative square root of 3 times square root of 3 would be negative 3. Negative 1 times 1 would be negative 1. And negative 1 times square root of 3 would be negative square root of 3. In the bottom, we get the first thing squared minus the second thing squared. So cleaning this up, we end up with negative 4 minus 2 square root of 3 over negative 2. And if I divide each of these things by negative 2, I end up with 2 plus the square root of 3. All right, we have one more example like that. Oops, I thought I had one more example. I do not have one more example of tangent. So we're looking backwards sometimes can help us think through each of these formulas. And so these ones are already applied in the formula. And so how do we undo this process? If we were to look at this, what I'm going to do is scan through my different options and find the one that goes in this order. Sine, ignore the numbers for right now. Sine, cosine, subtraction, cosine, sine. So as we scan through our options, look at your cosine of a sum, cosine of a difference, sine of a sum, sine of a difference, and find the one that goes in the order sine, cosine, minus, cosine, sine. And what you find is that is the sine of a difference, sign of a subtraction, and then we just fill in the two numbers that they have up here, so 42 and 12. If I do this correctly, the resulting number inside here should be something that is on my unit circle. Well, 42 minus 12 is 30, and sine of 30 degrees is 1/2. Same thing on the next one is find the one that goes tangent plus tangent, 1 minus tangent, tangent. And that's a tangent formula. And we just basically have to figure out, is it the one with the plus or one with the minus in it? So I just kind of look at the one on the top here. The one with the plus in the top is the one that had the plus inside the parentheses. Fill in the two numbers, 80 and 55. And again, at this point, if you fill these in and the result of that is not something on your unit circle, something went wrong. Let's see, 80 plus 55 should be 135 is on our unit circle. 135 degrees puts me into quadrant 2. In quadrant 2, tangent is negative, so my answer should be negative. That has a 45-degree reference angle and tangent of 45 degrees. Oop, whoa. Get rid of that. Sorry. Tangent of 45 degrees is 1. Negative because it's in quadrant 2, and tangent is negative in quadrant 2. Okay, guys, I understand that this is a tough section. I would go back, slow down the video, pause it, write your own notes, make sure it is making sense, try the worksheet before we get to our next Zoom session, and we will go through questions then.